as I explained in earlier class, right? Integral letters are basically any value which can be assigned to short, int, long, byte, float, and double, right? So we'll see what and all value we can assign to short, int, long, double, and all. Okay. So basically, in screen you are able to see that, right? There is a decimal, octal, hexadecimal, and binary. So these four number system values or literals we can assign to int, short, byte, long, and double. Okay, so now we'll see what and all which got included in decimal. Okay, so decimal is pretty straightforward. It's doesn't have much thing to like remember or a kind of note and all. So basically decimal any number which fall between 0 to 9. Okay, so any number which fall between, let me minimize this. So any number which fall between 0 to 9 are considered as a decimal number system. So let us assume if I declare, right, if I declare byte B, I am assigning 65. So 65 basically what? It fall in between 0 to 9. Okay, so this is decimal number system, and decimal number system, like all you know, they are having a base of 10. So basically when you go to the number system, so decimal number kind of 0 to 9 and having base 10, 0 to 7 I think, and base 8 is octal. Okay, binary 0 and 1 and base is 2. Okay, similarly we are having hexadecimal 0 to F and base is 16. 0 to F and base is 16, and this either small f or capital F. Okay, so we'll see this thing. First we'll go through decimal number system. So decimal number system, if someone asks, okay, what is decimal like in Java? So basically any program or any the day-to-day life we are using, right? So we are using decimal number system. Int a equal to 5. 5 decimal number system. So that we all know, and we already seen certain programs where we use a decimal number system, right? So we'll directly move to octal because we have some learning curve in octal, hexadecimal, and binary. Okay, so when you go to octal number system, right? So what happened? Octal number system basically a combination of any number. 1 second. Which a combination of 0 to 7. Okay, and in Java, right, octal number, when you are going to assign to any numeric data type, right, say float, int, and byte, then octal number will start with 0. Okay, so normal decimal will not, decimal number will not start with 0. So if you are having int a, if you assign a decimal, you can write 1 2 3. Okay, but you cannot use 0 for what? For decimal number system. But same int, okay, same int when you are going with what we call octal number system, you can have 0, 3, 6. Okay, so what it will do? It will convert this to respective decimal and it will get stored in A. Okay, okay. So basically, octal number system is a combination of a number from 0 to 7. Okay, if you go in deep into like if you study separately number system, you'll come to know that it's having a base 8. And what is the use of base 8 and base 16 or base 10 for decimal? When you convert from decimal to octadecimal, then there are certain formulas which we use where we utilize this base value. Okay, so basically here right now we are just learning about literals, so we'll not go deep into that. We have to know that, okay, exactly what and all value I can assign to. We should mostly will use decimal, but you should know that, okay, hexadecimal value also we can assign. Octal also you can assign. So in future if a scenario come where you supposed to use this thing, you can easily use. Okay. Octal literal must start with 0. Okay, in Java. So I will start like this is 0 1 0 1. So this is octal. 0 3 7 7 is octal. 0 3 4 5, this is also octal. But Okay, this is octal, and exactly what is not octal here? So let us assume if I take int a equal to 0, I started with 0, I take 3, 6, and 9. Okay, so any of you can say that is this octal literal or not? So any one of you, like, just second, I think someone, any guess? Poonam?
Yeah.
So this is octal or not? This value. So what I said, octal literals will be a combination of 0 to 7. Okay, and those literals start with 0, right? 1 second. I will explain again and you have to answer it. Okay. So this is octal. This is 0377 because it started with 0 and it's have all the number 377 which is less than 8. So this is octal. This is also started with 0 and this is also having all the number, all the combination of number which is less than 8, right? This is also octal. So now I'm asking you, 0369 is octal or not?
So you're asking about the 0369, right?
Yes, this one.
Yeah, that is not octal because we have nine
Yes.
in
So
that.
the basic fundamental of this class is to just to inform you, like we can, if you've seen this type of number assigned to any integer, short, byte, long, and all, right? So you should not get confused, and you have to be clear about that. If the number combination is not in between 0 to 7, it is not octal. It should be combination of 0 to 7. Okay, clear? So what is octal literals? So octal literals which start with 0, which are combination in between of 0 to 7 numbers, and what we call in Java, it always start with 0. Okay, this is not a case with decimal. Okay, similarly, when we go with hexadecimal, okay, so when we go with hexadecimal, so hexadecimal is a combination. Basically what happen, it will start with 0 and end with f. Okay, so hexadecimal numbers is a combination of 0 to 9 number system. Okay, and a small a to small f, or capital A to capital A, anything you can use. Okay, so basically what it happened, you might be all know. So it's go like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, not 10. Sorry. So after 9, okay, after 9, we are having A, B, C, D, E, F. Okay. So this is 9, A is 10, 11, 12, 13, 14, 15. So this is hexadecimal number. So in hexadecimal, whatever number you want to represent, you have to use these letters or these digits. Okay, clear? So if someone asks you, okay, so now you know that this is hexadecimal, but the question is how we can assign hexadecimal value to a Java variable. In Java, like in int data type, let assume you declare, let me clear this one. Let me clear this. Okay. So in Java, when you are going to, 1 second, let me take another color. Okay. So in Java, when you are going with hexadecimal, so let assume I am taking one integer, int a. Okay. So now I want to assign any hexadecimal value to it. So hexadecimal number should be combination of this 0, AF, or a small AF or capital AF. Okay, so we'll take one number, but always remember, if you are going to assign, 1 second, if you are going to assign octal, then the first digit of that number should be 0. In the similar way, when you are going to assign any hexadecimal literals to a variable, the first letter, right? The first letter either O, capital X, or a small x. Okay, understand? So 0, capital X, or a small x. Clear? Okay, so we'll take
Yes, sir.
one example of hexadecimal. Okay, so we'll assign just a simple. So I'm assigning 61. So this is 61 is a hexadecimal value. Why it is hexadecimal value in Java? Because we are using this prefix, right? If you not use this prefix, it will become normal decimal, right? So if you want to assign a hexadecimal value, if you want to do perform any operation on hexadecimal value while assigning, you have to use capital or small x. Okay, clear?
Yes, yes.
So basic idea behind this, you guys should know that how we can assign, if any hexadecimal value you want to assign to integer, boolean, sorry, not boolean, any numerical data type, right? So you can use this 0 and x. Okay, so capital X or a small x. Okay, clear? So nothing much in this. Okay, these all are like how to use literals and number system and all. Okay, now if anyone give you a program, okay, can you perform an addition of binary in Java? So yes, I can perform. So how you can perform that? Similarly, from Java 7 they have introduced or they start supporting, right? They have start supporting binary literals as well. So binary literals, what is binary literals? Basically a combination of 0 and 1. Okay, so we see here, so if you see here, 0 and having the base 2. So when you want to assign a binary literals to integer, short, byte, float and all, what you supposed to use? For hexadecimal you are using 0 and small x or capital X. For octal you are using 0. For binary what you will use? So when you want to assign a binary value, let's assume I want to assign binary value directly to any integer variable. So what I will do? Either I will use 0 capital V or 0 small b. Okay, so I am using 0 capital V. Okay, and now the value that I am going to assign should be a combination of 0 and 1. So 1 0 1. Okay, let us assume I declare another one b. It should be, I can use either capital B or small b. 1 1 1. So it's all 1. So okay, so like that you can form any combination of 0 and 1. So you know that if you are going uh, in decimal 5, what is the binary representation for that? So you can use that one and you can type in your notepad and all. I can practice that one. Okay, okay. So now very important that so hexadecimal is clear, which how we can assign hexadecimal value to integer. Now binary also clear, it doesn't have much thing or like much details. It's a basic like how we can assign a binary letters to a variable, either integer type, byte type, boolean or float type. Okay, so now we are going to floating points. Why we need to know must, like we should know must about floating points literal. Okay, so Which type of data types support floating point? Anyone can, like any one of you like can answer?
Yeah, with the floating point numbers, like with the decimal numbers.
Yes.
Decimal.
Decimal. Any floating point literals that we have, right? So for that we are having float and double. So by default, like if you take any value which is having the floating points, they will be by default double. Okay, in Java. If you want to that to assign to float, you have to, or those values should get assigned to float, you have to specify. Okay. Similarly, in non-floating, by default is int. Clear? Okay. So now floating points of floating point literals, how we can assign and all, we'll see. Okay. So when you let us assume you are having any value 123.45. So this value by default, so this value is by default double. Why by default double? So if you not specify here if, so it will by default treat it as double value. So if you want to assign this to float, or you want to pass this value as a float literals, then you have to use small f or capital F at the last, right? As a suffix. Okay. Okay. But double is D is optional. You want to use, you can use. If you don't want to use, you cannot use. So if you are taking 1, 2, 3, 4, 5, you can use a small d or capital D here as a suffix. Okay. Similarly, how for float we have. But if you not mention F or D anything, by default it will take D, which is clear?
Yes, ma'am.
Okay. Okay. Now,
I have a doubt. So, whenever we are creating any variable, we will be having the data type, right?
yes.
So there will be mentioning as a float, right?
Yes. But what happened? Let's assume you are having a two integer, right?
Okay.
And you are performing division, right?
Okay. Okay.
So that result by default it will come as a double.
Double.
So
Okay.
double is
Okay.
a default value. Okay.
Yeah.
Let's
Got it.
assume if you are passing, if you are specifically passing, let assume you created a method and you are passing the value from you are not aware about that. There they have double or float. If you mention f, then the argument which is going to accept that value, that should be float. Okay.
Okay.
So it's that is the thing. Okay. Then we are having narrowing and widening, that I will explain you later, like how it will get converted from the higher data type and all. Okay. Okay. So now for floating points, so we are having three floating point representation. Okay. The first one is standard floating point. Second one is exponent floating point, and third one is hexadecimal notations, which got introduced in Java 5. Okay. So mostly all of us, like even till now, I am using only the standard floating point. Okay. There is a very rare chance I have used exponent floating point, but I've never used hexadecimal notations. Okay. Clear? Okay. So we'll see what is standard floating point. So basically a standard floating point is any number which have floating points, right? 1, 2, 3.4, like day to day we are using, right? Like 76.5, 86.5. So they all are standard floating points. Okay. So I have given example of standard floating points. Here I have taken double, I have D, and then that D I have assigned 123.567, right? Okay, same thing I have did here. The second definition, second declaration. Okay, now third one come. I have assigned a float. Float f equal to 1.23. So this will not get accepted. You have to mention f here. So in the second example, I have mentioned f, right? Clear? So this is a standard floating point. So standard floating point, nothing like day to day what we are using. So for a standard floating point, we can directly use a double or float without, we don't need any specific symbol to define that one. Okay, clear? Clear, right?
Yes, sir.
Yeah.
Yeah.
Okay. So now you all, I don't need to explain this, this thing, right? After decimal, this is represent what and all. This is mathematical term. This is what and all. No, right? It will go like 10x smaller. This side will go 10x bigger, right? So every time
Yes.
you are going right, it will get 10x smaller. Every time we are going left, as per my sitting position, so this is left. Okay, so it will be 10x bigger. Okay, this we call, let assume, I will take an example of 2 digits, so it would be easy for you guys. Okay, so this will call, what we call this, tens, right? Okay, this is unit, right? This is decimal point. This is mathematics purely, like we all know that. But in this case, what, a 10x is smaller, 1 of 10th, right? 1 of 100, 1 of 1000, right? So this is basic, like this is not related to Java. This is basically related to school mathematics. Okay, I'm just explaining so that we should have a clear and all, like we should have clear idea on that. Okay, so basic floating is clear. Okay, now scientific exponent notation. So basically scientific exponent notation, why we are learning this, the basic things, when if you have to deal with this type of values, right? So it would be easy for you to write a program if you know that how you can represent this one. So if there is a scenario where you are having value like this, 123.456 multiplication of 10 to the power 2, then 123 similar thing here. So how you can represent or how you can do that in Java, right? So basically there are two type of values you will get. The 10, the power of 2 on 10 positive, and power of minus 2 on 10 which is negative, right? So how you can represent? So let assume if you have to represent this value in Java, okay, you have to represent this value in Java. So what you will use? You will use e plus 2. Okay, if you have to represent this value in Java, you will use e minus 2. Okay, a small e minus 2, not the power. This is not the power. It may seems like a pretty up. It is here. Okay, clear? Okay, so we'll see. We'll assign this value to a double. Okay, so let me see. So you can assign float, double, everything, no issue. Okay, so let assume if I'm taking first, I will take float f. Okay, and I have to assign this value. So I will 134 dot. Okay, now I have 8, 7, 6, 3. Let assume we are having e, and then what we can have e 2 plus 2 matlab positive 2. Okay, and then because it's a float value, I have f. Okay, so basically this value, what exactly this value is? This value is 134.87639 e to f, means we have to remove e, we have to present a multiplication and 10 the power of 2, right? So this value exactly represented here. Okay, okay, similarly we'll go with double. So we have take, it's clearly visible to you guys, right?
Yes, sir.
Yeah. So double D, let's assume if I have to represent the same thing, like the any value which is like 134, let's take this one only. Okay, I can assign to double as well. So I can do 134 dot 8763 I can use capital E 2. Okay, capital E or small e 2, anything you can use, no issue. Okay, let's assume this value is having minus. So just 1 second, I can take here, I can take a space here. So I will take a space here and then later I will remove it. Okay, so let's assume I am having double. Okay, having double D equal to, okay, so let's assume double D and the value would be 1 2 3 4 5 dot 6 7 8 9. Okay, now we are having E minus 2. Okay, so basically what does it mean? Okay, capital E or small e minus 2, anything we can have. Okay, so basically it means I can represent here 1 2 3 4 5 dot 6 7 8 9. Okay, power of 10 minus 2. Okay, here we are having multiplication. Clear? So this is called scientific and exponent notation. Okay, so the basic idea behind this, what you both have to remember, there is this 10 minus 2 can represent by E, small e or capital E minus 2. Okay, if it's having positive one, E2, this E2 or a small e2. Okay, clear?
Yes, ma'am.
Okay, so now come to this point. So scientific and all is not done. Now this floating point also have hexadecimal representation, which we call hexadecimal floating point. Okay, okay, so it's nothing, it's kind of similar. So any value, let's assume you are having any value, any hexadecimal value. So any hexadecimal value, the only thing you guys have to remember, you can use capital small 0 x ahead, and then you have your hexadecimal value here. Okay, so this, so I will give you one example and then we'll bind up this. Like mostly we have not, like we are not using it usually in the program, but because it's having a feature, so we have to know that. Okay, so let's assume I will take an example which, so I am taking a double. Okay, and double x equal to, so how will represent hexadecimal? 0 and x. Okay, now it has a p 0. So p is basically indicate the power. Okay, basically it's indicate the power. So 10. So 10 having a power of 10 multiplied by 2, and 2 is having 0 because after p we are having 0. So that is the reason. Okay, so it can get represented here like this: 10 into 2 0 equal to 10.0. Okay, so this we can represent like this. Okay, this is basically a hexadecimal representation. Okay, so you can have here p1. So what happened? This become 1. If you have p2, this become 2. If you have p3, kind of like that, then it's become 3. Clear? So it's nothing much here. We have to know that we can represent like this. That's it. So decimal or any decimal letter also we can represent by using hexadecimal number system. Okay, let me take 1 2 more examples so that otherwise you guys may let me delete this one. Okay. So it might get disconnected in 2-3 minutes. So let me quickly finish this hexadecimal or null letter. Okay. So double, let's take a variable a. So you can assign 0x a p1. Basically what happened, a is what? A is, so here we will go 10, right? After 9 we are having a, right? So 10 p. So p represent what? So p basically a power, the power on 2. So basically here what will happen? So here into 2 is having power 1. So when, so it's become 20.0. Clear? Clear all of you, right?
Yes,
Similarly,
sir.
similarly,
Yes.
similarly if I take b, so basic I'm just doing. So here you are having a p2. So what will happen? 10 into 2. So this is 4. So it's become 40, right? So this is kind of thing. Now we'll take another example. Double b, sorry, I have take c, 0 x, small x, and then we are having b p power of 2. So what could be the value? 11 into 2 to the power 2. So it's 11 into 4. So 22, sorry, 44.0. Okay, 44.0. Clear? 1 second.